learn about class 11 maths topic trigonometric functions. So let's start today's class. So dear learner, first we will focus on the unit circle and trigonometric functions. So what is the relation between a unit circle and trigonometric functions? So here I have a unit circle, center at O and radius OP. This radius is a unit radius that is equal to 1. Now, if you see that in class 9th and 10th, we studied about the 6T ratios, that is sine, cosine, tan, cotangent, and secant and cosecant. So, if I see this OM will be the base for this triangle. If this angle is X, then OM will be the base of the triangle. So, OM upon OP, base upon hypo will become cos. So, it will become cos X. Whereas my OP is 1 unit, so OM will be equal to cos X. So in this unit circle, this radius is OP and then OM will represent, this length of OM will represent cos X, the value of cos X. Similarly, if I see PM upon OP, that will become perpendicular upon hypo, that is sin X. And as OP is 1 unit, so PM will be equal to sin X. So this is my sin X. This length PM will represent sin X. So now our cos X is equal to A and sin X is equal to B. This cos X is equal to A and sin X is equal to B. So in triangle OMP, I can say that OM square plus MP square is equal to OP square. Pythagoras theorem I applied here. So, or we can say that A square plus B square is equal to 1. For every point on the unit circle, this relation will be true. What is A? This length A is equal to OM is equal to cos X. So, replace this A with cos X. And as my B is equal to sin X, so replace the B with sin X. So I got a identity that cos square X plus sin square X will always be equal to 1. Now what's a quadrant angle? So if I move this radius OP throughout the circle, if I make the complete revolution of this radius, then what will happen? It will rotate by the angle 2 pi. So at point B, if I do the 4 equal part, so this at point B, this radius will be at an angle of 90 degree, that is pi by 2. At point C, it will be angle pi. At point D, it will be 3 pi by 2. And again at point A, it will complete its rotation and it will become 2 pi. So these angles, pi by 2, pi, 3 pi by 2, 2 pi. That means the multiples of pi by 2 are known as quadrantal angles. Quad stands for the 4. So when I do the 4 partition of this complete angle, so each multiple of pi by 2 is known as the quadrant angle. And the coordinates of the point A, B, C, D will be, the point A will have the coordinate x axis, that is 1, and on y axis it will become 0. And point B, it will be 0, 1. Point C will be minus 1, 0, and point D, here the value of x is 0 and value of y will be minus 1. So how they are useful for us, these quadrantal values? So we can find out the values of t ratios at these quadrantal angles. See, if I am at this point A, that means my radius will keep on reducing like this, and when it will match with line OA, that means the value of x which keeps on reducing like this, so it will become 0. So it will become sine 0. So length which was OP, that will also keep on reducing, and at this point the value of sine 0 will be 0. While cos x, this OM will be extended up to OA. This will become equal to OA and the value of cos will become at angle 0 will be 1. So you can see that this x coordinate is representing the value of cos and this y coordinate is representing the value of sine. So at point B, what will be the value of cos? It will be 0 and the value of sine will become 1. So sine pi by 2 will be 1 and cos pi by 2 will become 0. At point C, the cos will become minus 1 and sine will become 0. And at point D, the cos will become 0 and sine will become minus 1, and at point A again it will be similar to the values given, that is 0 and 1. So now you can observe it carefully that sine will be 0 at 0, at pi, at 2 pi, whereas cos will be 0 at pi by 2, 3 pi by 2. So we will use these results to define the more t ratios, that remaining 4 t ratios in terms of sine and cos. So this is my curve of sine x, and if you observe that after every interval of 2 pi, this is 2 pi, curve attains its maximum value as well as minimum value and it will start repeating itself. If I go further this, again up to 2 pi, it will be the same as the previous one. So I can make the partitions of 2 pi. Similarly, negative side also we can make the partitions. So that means after an angle of 2 pi, curve will repeat itself. So we can say that the period of sine x is 2 pi. So sine 2n pi plus x will be equal to sine x, where n belongs to integer. That means as many interval of 2 pi we can add in the sine x, the value will remain same. Second thing, if we observe carefully, then at 0, at pi, 2 pi, similarly minus pi, minus 2 pi, 3 pi, minus 3 pi, 4 pi, minus 4 pi. So sin x will be 0. At these points, the value of sin x, that is the y, will become 0. So when x is an integral multiple of pi, the sin x will become 0. See, all these are the integral multiple of pi. 0, plus minus pi, plus minus 2 pi, plus minus 3 pi. So we can conclude by this that sin x will be 0 if x is equal to n pi, where n is any integer. This is a very important result, that sin x will be equal to 0 when x is a multiple of pi, where n belongs to integers. So let's check about the cos x. So this is curve of cos x. And in cos x, if we see that it is also same ways as sine was, at the interval of 2 pi, it will start repeating itself. So everywhere, if I make the branches of 2 pi, it will start repeating itself. Similarly, this side also we can check. So at the interval of 2 pi, every 2 pi, curve will start repeating itself. So cos x will also have an interval of 2 pi. So cos 2n pi plus x will be equal to cos x, where n belongs to integers. Second thing, when the cos will be 0, now cos will be 0 at pi by 2, at 3 pi by 2, 5 pi by 2, 7 pi by 2, 9 pi by 2, minus pi by 2, minus 3 pi by 2, minus 5 pi by 2, minus 7 pi by 2. Likewise, that means when x is an odd multiple of pi by 2, 1, 3, 5, so an odd multiple of pi by 2. So whenever angle is an odd multiple of pi by 2, cos will become 0. So we can conclude that cos x will be equal to 0 implies x is equal to, here I written the odd number as 2n plus 1, because 2n always an even number. If I multiply a number with 2, it will become an even number, and if I add even plus 1, 2n plus 1, it will become an odd number. So odd into pi by 2, that is n is any integer. So now let's discuss trigonometric functions in terms of sine and cosine functions. First of all, let's discuss about cosecant x. Cosecant x, as you know dear student, cosecant x is reciprocal of sin x 1 by sin x. and it will exist when x is not a multiple of pi, because at the multiple of pi sine will become 0. Sin x will be 0 when x is a multiple of pi. So we will remove all the angles where this sin x will be 0, because if it becomes 0, it will lead to infinity. So cosecant x will not exist. Next is secant x, which is reciprocal of cos x, and as you know that cos x will be 0 at odd multiple of pi by 2. So we will remove all these angles from its domain, that x is not equal to odd multiple of pi by 2 where n is any integer. So whenever I use this function secant x, I mean that my angle will not be odd multiple of pi by 2. Tan x, its denominator is also cos x. So same condition applied, that cos x should not be 0. So x should not be equal to odd multiple of pi by 2. Whereas in the cot x, the denominator is sin x. And sin will be 0 at the multiple of pi. So the same condition is applied as cosecant x. So cot x will exist only when x is not a multiple of pi. So values of trigonometric ratios we studied in class 10th also. So let's revise that. Sin x, as you know that the trick how to write down all these values. So 0, 1, 2, 3 and 4 up to pi by 2, that trick works. Huh? So it will be 0 by 4, 1 by 4, 2 by 4, 3 by 4 and 4 by 4, and make the square root of all the values. We will get the values of standard values of 0, pi by 6, pi by 4, pi by 3 and pi by 2. So this will be 0, this will be 1 by 2, this will become 1 by root 2, and this is root 3 by 2, and this is equal to 1. Don't go beyond this 4, because sine will not have the value more than 1, because where we sine exists in a unit circle, and in a unit circle it cannot go beyond 1. So at pi, if you remember that our circle, so when angle is pi, so the coordinates of this point will be, point C was, the coordinates were x was -1 and y was 0, and the value of y, that is the sin x. So sine will be 0. And at 3 pi by 2, sine will be equal to -1, and at 2 pi, again at point A, if you remember that circle, so A, B, C and D. So at point A, 1 comma 0, so the cy coordinate is 0. So cos will become at A, and that is 0 degree, cos will become 1. B, that is pi by 2, at pi by 2 it will be 0 comma 1. So that is pi by 2, cos will be 0. At C, cos will become -1. At D, cos will become 0. And again at A, it will become 1. Okay, that's sufficient for us. And the remaining values, we know that sin x, and just reciprocal this, repeat this, change its order, root 3 by 2, 1 by root 2 and 1 by 2 and then 0. And if we know that sine and cosecant, we can find all other t ratios. That we know that cosecant x is a reciprocal of sin x. So cosecant x 1 by 0, that is not defined. Whereas reciprocal of 1 by 2 will become 2 by 1. Here it will become root 2 by 1. Here it will be 2 by root 3. Pi by 2 it will become 1. And at again 0, so not defined. Again -1, reciprocal of this will be -1, and whenever sine is 0, cosecant will not be defined. Similarly, secant x, if we see, it will be the reciprocal of cos x. So 1, 2 by root 3, it will become root 2 by 1, it will be 2 by 1, it will be not defined because cos is 0 here. So sec will be not defined when cos is 0. Reciprocal of -1, and reciprocal of 0 is not defined, and it is 1. Tan x will become sin x by cos x. So 0 by 1, 1. and if I divide them, it will be 1 by root 3. Sine by cos, if I do the same values, both are, so while dividing it will become 1 root 3 1 by 0, that is not defined. 0 by minus 1 0, and it is not defined, and it is 0. So cot x will be cos by sine, so 1 by 0 it will be not defined, and if I divide them, then cos by sine it will become root 3 1 1 by root 3, and 0 by 1 will become 0. And when it is minus 1 by 0, cos by sine if I do, it will be not defined. Whereas 0 by 1, 0, and 1 by 0, again not defined. So that's what we extended the table for these new quadrantal angles also. So sign of trigonometric functions. So once again we will focus on this unit circle. In the first quadrant, quadrant means when I go counterclockwise direction, to 0 to pi by 2, it is treated as the first quadrant. So this is first. In math, a counterclockwise direction is always considered as the positive direction. So pi by 2 to pi will become my second quadrant, and third quadrant will be pi to 3 pi by 2, and fourth quadrant will be 3 pi by 2 to 2 pi. This is my fourth quadrant. So here you can see that x and this perpendicular, this base and perpendicular, both are positive. So if base positive, perpendicular positive, and hypopositive, so all the t ratios will be positive in my first quadrant. While in second quadrant, my base, this line will become negative. So as we know that sin x is perpendicular by hypo, so base is not involved, so it will be positive, because perpendicular is positive but my base become negative, and cos x is base upon hypo, so it will become negative. Okay, sine positive, cos negative, then tan will also become negative, then cot will become negative because reciprocal of tan will be negative 1, and cos reciprocal will be sec x, that will also be negative, and reciprocal of sine will be cosecant x, that will be positive. So two t ratios will be positive here, that is the sin x and cosecant x. In the third quadrant, where base is negative and perpendicular is also negative, so here tan and cot x will be positive, and the remaining t ratios will be negative. And in the fourth quadrant, as my base is positive but perpendicular will become negative side, so wherever perpendicular is involved, that will become negative. So cos x will be positive and its reciprocal sec x will be positive, remaining t ratios will be negative. And I'm helping you with a hint that how to remember that. First, let's make a chart. So in first quadrant, all are positive. In second quadrant, sine is positive and its reciprocal is positive, that is cosecant x. In third quadrant, tan and cot positive. In fourth quadrant, cos and sec x are positive. So we can learn them via easy sentence that add sugar to coffee. Add. This A stands for, in first quadrant, all positive. In second quadrant, sine and its reciprocal positive. Third quadrant, T, that is tan and its reciprocal cot positive. In fourth quadrant, cos and its reciprocal, that is secant positive. Or you can make another sentence like that. Assam State Travelling Corporation, after school to college, so many, as it's your wish that how you learn them. But in first quadrant, remember, all are positive. In second quadrant, sine and its reciprocal positive. Third quadrant, tan and cot. In fourth quadrant, cos and sec are positive. So now let's discuss about the domain and range of trigonometric functions. So first of all, let's discuss about sin x. So here I sketch the curve of sin x. So it will help us to understand the domain of the sin x. So when I'm talking about the domain of sin x, my means that the values of x where the curve exists. So you can check that curve is a continuous curve. Everywhere it is a continuous curve. So no issue with that curve. So curve is continuous means it exists everywhere with all values of x, some value of y exists for that. So my domain will become all real number. Wherever, if I am talking about range, you can see that I had drawn two purple lines for the maximum and minimum. And you can see that curve lies between these two lines only. That maximum it goes up to 1 and minimum it goes up to -1. So that means all the values of y, all the values of these functions are lying between -1 to 1. So its domain will become all real number, whereas range will be from -1 to 1. Let's see about cos x. So here is a sketch of cos x. So likewise sine, for all the values of x, curve exists. Yes, curve is existing for all values of x, so domain will be all real number. Whereas, and curve lies between, the value of function lies between -1 to 1, so its range will be from -1 to 1. All the values of function lies from -1 to 1, so range will be same as the sin x, that is -1 to 1. Tan x. This green line is representing the curve of tan x. As we know, tan x is sin x by cos x, and wherever cos x is 0, curve will lead to infinity. Wherever my denominator will become 0, curve will not be defined. And you can see that at pi by 2, curve is leading towards infinity. At 3 pi by 2, curve is leading towards infinity. So curve does not exist. Wherever cos is 0, curve will not exist. So what will be the domain of this curve now? So domain of the curve will become all the points where the curve exists. So it will be all real number except whereas this cos x is 0 and cos x is 0 at odd multiple of pi by 2. So I can say that domain is all real number except these points. And what is the maximum value? It's keep on increasing because it's leading towards infinity, and this side it is leading towards minus infinity. So minus infinity to curve is leading towards plus infinity. So all the values are included in this curve. So its range will be all real number. So domain will be all real number except odd multiple of pi by 2, whereas range will be the all real number. So cot x is almost same as tan x. The only difference is cot x is equal to cos x upon sin x. So now think about this, where this curve will not exist. This curve will not exist wherever sin is 0 and sin x is equal to 0 when x is a multiple of pi. And we can check that at 0, at pi, at 2 pi, at 3 pi, all these dotted lines, there the curve is not defined. So we will exclude all these points whereas sin is 0. So our domain will become all real number except these points where sin is 0, that is n pi. Whereas range, if we see, the value of function will leading towards plus infinity, and if we go downwards it will going towards minus infinity. So that means all the real values are included. So its range will become all real number. So let's note it. Domain is all real number except multiple of pi, where the range is all real numbers. Cosecant x, reciprocal of sin x. Cosecant x is the reciprocal of sin x. So on the same lines, it will also not exist wherever sin is 0. And sin is 0 at pi, 2 pi, 3 pi. So we will exclude all these points. So domain will become all real number except multiple of pi. Whereas if I am talking about the range means value of the function. That is either more than 1. You can check that within this area no curve exists. I draw this line also, brown line, to understand it more clearly, that either it is existing more than 1 or it is less than 1. So I can say that it is either minus infinity to -1 and 1 to infinity. Or in other words, I can say that it is all real number except -1 to 1. So both the ways are correct. So our domain is all real number except multiple of pi, whereas range is all real number except this portion -1 to 1. We will remove this much portion. And our next sketch is sec x. So it is 1 by cos x. So where the curve will not exist? Wherever this cos is 0. So it will exist everywhere except where cos is 0. Cos is 0 will be at 2n plus 1 pi by 2. Odd multiple of pi by 2, you can check that at odd multiple of pi by 2 curve will lead to infinity. Minus pi by 2, minus 3 pi by 2, minus 5 by 2. All these at odd multiple of pi by 2 curve will not exist. So our domain will become all real number except odd multiple of pi by 2. Wherever range is, if I am talking about, so range is the value of the function that is either more than 1 or less than -1. So all real number except -1 to 1. That is the range. So this is my domain and range. So hope you understood this concept. Thank you very much for being with us.